Hello guys to another tutorial. In this case we will be learning how to create incredible smoke simulations and how to scatter them in Solaris. So stay tuned and watch the full tutorial. Guys, do you want to join a really nice server? We have tons of different channels. We have effects, modeling, loop dev, compositing. We will have resources for every type of discipline. I also have a Patreon page where you can support me. I have every single file, I have polls, I have even some tools, guidance. So if you are interested, you may have a look. Thank you. So it all begins with a simple sphere. This sphere is just squashed to the bottom. And then I have a node called Pyro shape where I'm doing a bunch of stuff. Basically, I do have velocity, temperature, and density, and I can preview my velocities. How is all this done? Well, with a bunch of nodes, but basically to just make it super easy for you guys and you can recreate it, you can create a nice offset, and then you can call this density. You can increase the amount of resolution over here, for example. This is okay. And then with a volume noise fog, you can then multiply and enable a ramp. So then you can have a noise. That's one way. This works great with the same is offset. So you can just then name this differently. For example, I want this to be called temperature. Now this node is going to be called temperature. So then you will be able to merge these two guys together. And you can see now we have two different things. That's one thing. Of course, you can also animate this with the animation. And then you could, for example, use a volume velocity. Then you can have a lot of things over here. You need a velocity volume. So you could just BDV here, BDV activate, and use regions to activate. This will be called V. This will be also called a vector float, and you will reference this. Now you have a velocity. So if you plug this in, you can then, I don't know, for example, add a curl noise, or not even add. You could just set this to 0 and then use the velocity and add this swirl size. And that's all there is. There's not much to it. If you want to visualize, you can use a scatter on this offset. And then you could potentially trail volume. So then you can use the points to trail with the volume. So now you could just, for example, increase or decrease, offset this, change the turbulence, and do a bunch of stuff. So all of these guys combined will give you the volumes. In this case, the Pyro shape is a little bit easier since I can go one by one and I can modify, for example, the ramp as I please here. That's one thing. I could also add a fall off. Now it's on the X size, but it could be on the Y, you can see, or on the Z, as you can see. Radial too. This is something very nice. I can increase the radial. So pretty cool stuff. Or I can just disable this altogether. There we go. Something to fix. Then I can preview either my geometry or if I have velocity, for example, my velocities. And I can do exactly the same thing to make this work. Now, what I did is to create a simple sphere with some density, temperature, velocity with a box size of 0.25. Then I used a box. And nice trick, what I did here is to have a velocity. This velocity would be dragging the values. Right now you will see this is on 0 because it's the wind force, but it's on a wedge. So if I generate static, for example, on this one, we should have a wind force of 1. So you could control this all together. So you have more wind at the top of our simulation, right? So this will be called wind. If we merge all of this together without previewing, there we go. Now we have a velocity and a source over here. We'll see these changes with a different amount of velocities which are added here. We will disable the visibility because I really don't care. And let's just go to here and add this by 4 so I can actually show you guys what's going on. So sourcing, I'm sourcing density, the temperature, and the velocity, but I'm also pulling with direction strength using my wind targeting my velocity. So scale of 13. Basically, this is a way to add wind. This is the best way. You will change the vector of the wind slowly. And there's something else here because I'm adding a way to have color. Let's go just 1 frame forwards. You will see I have color. How did I do this? There's going to be a reference to Adult Jump Academy where I got the idea from. And in one of the videos they show like a little toolbox where I just did reverse engineer. But basically I'm just emitting rest. I mean, here, yes, I'm emitting rest once, and then I'm setting the rest every time step, and I'm setting these frames very long into the future so it doesn't reset. So each frame I'm just advecting my rest field. This is not a dual rest field, it's just a rest field. Basically I'm just adding color in a UV pattern shape, so you can use it later on to just drive some color from it. So you have a something which is called gas resize field, which I'm using just so I can enlarge the density, the rest field based on the density. Otherwise, I don't know if there's another option. The rest field wasn't actually working. So, and finally, disturb set to rotational with this strength and this block size. Nothing else. There's no control field whatsoever, only in this one, which I'm using density. But it's basically just the same thing with different settings. In this one, I'm like getting more volume out of the in the equation, and here I'm using less. And it's just changing the strength and the block size. The smaller I'm going, it should be the other way around. But the smaller I'm going, I usually tend to go on smaller values of strength. And a gas water confinement just set to 0.2. So it can rotate over itself. And a radius of 0.5 to the gas blur to just not make it so sharp, because I don't want this to be so sharp. So once you have this, if we press play, this is okay. You will see that the colors are working. So I could see here, this is a nice way to see. I could see with a volume visualization how is it working. In this case, I'm just remapping the rest with these values, but it's not actually going to work if we are going to be using those RGB values. So the way to go is to actually test it out, sampling some colors. So we have this rest, which I'm calling now CD, and I'm smoothing them out. Then we're having a grid with a mask on top of it, and I'm renaming the mask here with the red, green, and blue is just to pre-visualize it. And then I'm setting this to black and white. But to pre-visualize, what I'm doing is here, I'm testing, I'm visualizing if we have all the colors, red, green, and blue. So this means I have a really nice dynamic range of colors. What's going on here? It's just a null button connected to an if clause. This color is basically this ramp, and otherwise it's a preview ramp. So these are two different ramps. I'm just switching from one another. This is the way I did. I just added a boolean. Where's the boolean? A toggle here, 2G. And then I'm hiding where the toggle is set to 0 or is set to 1. So I'm just switching between each other. And what's going on inside here? Well, it's extremely easy. It's just a pop open, whose radius is set to 50 in this case, with a pop filter looking for CD and outputting CD on the volume. I'm using the second input, because this is where I'm getting the value from, the colors. And this is just me having a CD. Remember that this is like an UV or raw position data, so you can actually add it together with a turbulence noise in order just to add a little bit of noise to the mixture. Well, in this case, it's very low resolution, so it's not going to be noticeable, but it does add a little bit more to it. So you'll see how this works. It just works. Have a nice value here, and it will drag over. And with the preview, you can see what's going on, and you can actually change, if we transform this all the way, that we can actually move the color after simulation. So the nice idea from the Double Jump Academy folks. Well, I got the idea from there. The rest field exists years ago, but if you haven't been using the legacy solver, the workaround was a little bit complex, but I'm sure they will be adding something related to it in the next version. I hope so. So then I'm just using a file cache because I want to iterate and have different volumes. So what I'm doing is wedging this, adding 4 because I want 4 variants, having a wind force set to 1 to 0.2 and dissipate from 0.02 to 1. And basically it will go to the dissipation. So the further I am, like for example here, this value will be changing. Calling rate 2.2, advanced, always BFECC clamp, and I'm using these fields to advect. Well, I'm not longer using rest 2, so it doesn't really matter. And I think this one doesn't really matter, but I'm just keeping them there. Then I'm outputting all density rest vel and converting BDB using 16-bit float and resample volumes bell and rest set to 2. I don't need that much detail here. And using speed just in case. And I think that inside here there's a dissipation, which I think I might not be using anymore. Let's look for this dissipation fields. Oh yeah, here, dissipation, dissipate. And those are all the things. You can actually check they are no, they are not connected because it's just a global variable. And then you save in background. This is scheduling, so it's basically how you are handling it. I have 64 cores, and then I have a total count of less than 1, and I'm using 1 batch at a time. This is very important. So the way to do it is to remove the simulation and time dependent, and then if you also, let me check, if you also, there we go, time dependent, it should be okay. But you need to remove the simulation, then click and then go back and simulate. It will hide again. All together that, yeah, then you need to wedge this to merge. Instead of merging everything, you need to use $wedge, because for the next step, we are going to loop over these guys. If we choose, for example, the latest one, erase static. Here we go, the latest one. So this is going to be looping over everything. Literally over everything. This was modified because I'm using another. I was testing something, this didn't work. Just use self. Don't touch anything. And this is very important. I'm going to show you once we go to Solaris. But altogether, this is very nice. Remember, you should be keeping to black and white when you export this, so you can then remap the value. So for example, let's say that we are going to be using black and white here as our example. So if I go over here and if we remap this, this should be set to CD. Now I can use these colors to test with a black and white spectrum, which is very nice. So this is, you can have this then in shader level. So just output a black and white mask. I would have liked this to work on float, but this now, I don't know, it wasn't working for me, so I just kept everything into CD, which is a little bit more expensive, but it's the same. It doesn't really matter. So after this is looped, you can see we have different colors. Ignore the colors, it's not going to do anything. We have all the values here, 6 BDB volumes. And we're loading specific wedges in this case because I just chose 2 wedges for the simulation. And well, before going to this, let me just real quickly just show you one of these volumes. So let's go into Solaris just for a quick second. No, not a null, but a sump imp. So if we grab this, you will see that the volume is being saved differently than you are used to. Why is this so? Well, there is a parameter, if you go over here, which is just being called ESD volume path. The ESD volume path is basically this, a way to save the path of the volumes. I want all this, which is saved iteratively, to have basically the same file cache path. If we were to change, for example, this, it will change the value here. And if we change it here, it will just change the folder name. So what I'm doing is per wedge, basically per wedge, I'm changing the names of these folder structures. So when we have more than one, they're saved differently. That way we can actually instance them in Solaris with more, being a little bit more easier for us. That's the issue. I mean, that's the thing. And then what I'm trying to do in order not to change per volume the frame so we can have more variation, I'm just adding 120 frames and then I'm looping. So this is the frame. I just added a float. Yeah, I just did a float here and drag it over there. And then I added this function because I knew I have 240 frames and it's started on 101 and 1001. So with this thing, it is just going to be looping over and over and over and over. And since it's also looping, it will be seamless once we render it. It won't stop the cache. And on advanced, I'm just changed the frame for this function. It's just exactly the same. In fact, I could have deleted this. I don't know why I'm using it, but you can just plug in the value here and it's going to work. And I'm using this one, use the volume path, replacing everything that has this with extra. And since I only have one, you'll see here, since I only have one dash, which is invisible, that is over here, dividing the B0 with this inner volume. If I do this, boom, it's going to change. That way, I can have 4 volumes instead of 2, which are combined, and I would have been losing them. So this is very essential. That's just one thing to keep in mind. And I think that's it. I've left another one for medium volumes. This is for large volumes. So let's go into Solaris right now. Let's not use this. So I have a primitive, which I'm just creating the scene and the camera. I don't know why it's not appearing here. Oh, there we go. The camera and the lights and the scene. And I'm setting the camera inside the camera. So I could just visualize over here. And I'm saving the animation. I'm instancing a lot of smokes. But firstly, I'm creating and bringing in all the volumes. B0, B0 extra, B1, and B1 extra. And I'm saving all into a medium smoke. Well, this should be large, but don't worry. All into this collection. The collection will include all of these smokes values. So all the wedges and all the inside volumes. So we have a place where to choose from. And if we go inside the copy to points over here, you will see that I'm saving into prototypes all the volumes over here very nicely. So I'm having like a lot of volumes inside here to see. This is slow. I could have another value, like we could configure primitive. And there's something over here, draw mode. Here we could use bounded box. So for example, I believe we could use this one. Does it work? Kind of. Okay. Yeah. Now I'm using boxes for everything. In collection, copy to points. Oh, it's not working. Maybe I need to do it over here. Is it working? I think not. Well, anyways, it's laggy on the viewer, but if you go into CPU, it's extremely fast. Extremely fast. So that's here. So I did an animation with the camera, which I then saved to disk, which is just moving in space. And inside here, what I did is to create a high fill over here with a simple noise, nothing really crazy. I converted this into height fill. I frustum this over here, and I turn shifted this to the first frame of my animation, or here. So now I have less geometry to then displace, and I'm scattering over the whole surface and also frustum just the points that I need. This tool is available on the Patreon, guys. And I'm turn shifting this again, having a P scale, having a mask, which is going to be useful later on for shading level, and transform this lower a little bit. So this is the camera, and the camera I'm using is the looping port, which is basically is the same camera over here, the same one, but brought into subs and then brought back into loops references. So what can happen with this, as you can see, there are different volume sizes and whatever, is that I'm playing with my P scale. And look at this. This is extremely fast, and I have I have hundreds of volumes here. Well, I don't know, 100. Yeah, 100 and something volumes over here. We have a mask. The mask is going to allow us to do some shading later on. But yeah, it looks pretty nice in my opinion. I don't know what you guys think. Then we bring again the mountain. Now it's in the mixture again. And then we are going to add a material library to this. This is initializing, but it is initializing because of the ground, I believe. So what is going on here? Basically, the smoke is just a Karma Pyro shader, and I'm using the mask to drive the hue of a color correction, which is driving the CD, which is using some values. I'm using these values. It doesn't really matter. For example, this one is the most close to it. If I change this value, it's going to change. This is just changing the hue. And since all of these have different values of mask, all of them are going to change in hue. And this is just I'm multiplying everything. So I can have more, I can have black or more whitish values. Remember, all these masks are going to 0 to 1. So then I'm remapping this to 0.5 to 1. So I don't have these dark volumes over here and there. And everything's set to smoke color. Then set to scale to 3. That's it. On the ground is just a regular displacement. Nothing else. Seriously. With a simple downlight, it looks something like that. And using this one, I'm actually adding more dicing to the ground, so the displacement works better. As you can see, it has more detail. And then I'm phantom everything, removing the primaries. Then I'm just revealing the ground. Yeah, I'm revealing the ground, so it's only going to give the ground. And then here what I'm using is just revealing the smoke and matting the ground from the rocks, which I'm also reducing the dicing so it doesn't take so long. Over here in the Karma, I'm using XPU because it's faster, but here I'm just using CPU for the sake of the video. There we go. Sorry, it was loading. Which looks very nice. Super simple. I'm just having motion blur, no depth of field. Limits using only this because it's just a ground. I don't need much more. And for the volumes, the limits are going to be changed to 3. So it has more color to it. And I'm saving all of these to disk. To sending this to render. You could use such as a regular render ROP. I mean, use the render, like render this one, and you could save it to disk. And that's about it for the simulation aspect of this. Hey guys, I'm glad that you watched the tutorial. If you need anything, please leave a comment. I will be there for you. Yeah.